Okay, Chapter 4, Basic Instructions. Guys, we've already seen a few of these, and by the time you turn in Assignment 3, you will have used a few of these. So let's get started with probably the most common and the simplest to understand instruction, and that's the move instruction. When we go over instructions, I need to tell you the rules, so what the instruction does, what size can the operands be, what addressing modes are legal to use, and what effect will the instruction have on E-flags. So let's go through that for the move instruction in particular. So it moves a value from the source to the destination. The destination will be overwritten. The source is unchanged. The size that's allowed for the move from source to destination, the move can be byte, word, or double word. The size of the two operands, however, has to agree. That's going to be the case for most instructions. Okay? We also said that the addressing modes have to be defined. So for a move, the destination can be either memory or register. The source can be memory, register, or an immediate value. And then for E-flags, let me talk real quick about how E-flags might be affected by any of the instructions that we talk about, and then we'll hit move. Or we'll hit move as we go. So, E-flags is going to be affected in one of three different ways. Number one, no effect at all. Okay? That, by the way, is the case for the move instruction. E-flags will be changed only when an instruction is evaluated in the ALU. If the instruction does no arithmetic or logical operation, as is the case with the move instruction, then it will not affect the flags register. So, second though, some flags will be affected depending on the results of the instruction. So, let's say status bits in E-flags are affected. And then finally, the third case, status bits are affected, but it's not predictable how they're going to be affected. This is going to be the case when we talk about the division instruction. Okay? So, a big why question that comes up is, why is it the case that the move instruction doesn't affect a change in E-flags? So you need to know the answer to that. Why? Remind me, and we'll talk more about it again in class, because I promise you'll see that. Okay. For each instruction, as we go through it, but especially with the move instruction, we want to spend some time talking about how each one of these instructions is encoded. So how do I take that assembly language, do the direct translation, line for line translation, from assembly language to machine code, ones and zeros. So we're going to spend quite a bit of time in class talking about that, but for right now I wanted to just tell you it's there. For now, let's go back to something I mentioned as part of the rules for any of the instructions, but in particular the move instruction. And that is, not all logical combinations of source and destination operands are allowed. For example, it is not allowed for me to go from memory to memory. Not allowed at all. Okay? There are also some other combinations that are not allowed, but let me just quickly talk about why that is. First reason, the obvious reason, is there is no opcode in the instruction set, so the designer of the instruction set did not allow for that combination. The second reason, though, is the reason why they didn't allow for it. Imagine, if you will, remember every instruction is going to go through the instruction execution cycle, and we know that the system bus is the bottleneck, so we want to minimize trips across that bus. Think about how many trips I would go through if I am moving something in one place in memory to another place in memory. Think about how that would be even worse if I were doing something besides a simple move. So, for that reason, this combination, you will not see it in any instruction in the x86 instruction set. Well, there are some other things that are also not allowed. So any one of these things, what do? Well, let's kind of hit them one at a time, some quicker than others. What if I need to move something in one place in memory to another place in memory? I can't do it directly. Hopefully I'm not going to do it very frequently at all. But in the event that I really do, what I could do is move count to a register. In this case, we'll use EAX, and then move that register to sum. This will have the same effect as what we're not allowed to do. Okay? Plus, I'll talk a little bit, this has something to do with how instructions are encoded. This instruction will have a different opcode than it would if we were using EBX, for example. There are instructions where if I use, that allow me to have special use of the accumulator or some form of EAX, in other words. So I want to look for those opcodes. Those are going to save me a little bit of space. So in this case, in this first case, I'll have an opcode that says I'm moving a value in memory to EAX. I already know EAX, so the only thing I don't know is where the value is. So this is going to take 5 bytes instead of 6 bytes if I were to use EBX, ECX, EDX. Okay? Alright, well, what else can we not do? Or at least not do directly? Immediate to segment register. I cannot move an immediate value to a segment register. Are there ways I can do it? Yes. Why won't it let me do it directly? It's protecting itself, okay? So the designers of the instruction set, you know, we really don't want people to accidentally overwrite the address that's in the data segment register. So we're going to make that impossible. However, if you really know what you're doing, and you really know you want to do that, just again, do it in parts. So in this case, what I would do is, let's move 16 to AX, and then simply move AX to DS. That is legal. Okay? Alright, next thing on the list was setting E-flags or overriding EIP. These are not normally allowed, or affecting E-flags or EIP in this way is not normally allowed. The reason why is pretty easy to understand. Again, the machine or the system, the designers of the instruction set do not want you to be able to do things that you really shouldn't do. Changing E-flags, or especially changing EIP. Now, what if we need to modify them? Then we need to change privileges, okay? Normally, if you have administrator privileges, super user privileges, root access, then you can directly modify them. In this class, though, we won't. Okay, again, that's really more of a protection than anything. Okay, we had some other moves in there. In this case, what if I want to go from 16-bit to 32-bit value? I would need to sign extend that, and we have some special instructions that will let us do that. We'll get to those a little bit later. Or what I could do is something like this. If I want to move into EAX, here I'm moving a 32-bit value into a smaller register. In this case, what I could do is double val. So I'm moving some double word value into EAX. But now what I can do is move just a portion of EAX to byte value. Okay, so I can do something like that. I can go the other way by clearing out. If I want to move byte sum into AL, let's clear out EAX before, and then move EAX into double val. So I can do that. When I'm moving values in several steps, like I'm swapping, well, let's just go to swapping. Swapping is probably one of the quintessential algorithms that you learn, and in fact, it's one of the first ones you learn. You learn it in 1430. It's an important one. What if I want to swap the contents of two registers, say EAX and EBX? Well, first thing I'd do is let's move EAX into a dummy register or dummy value. So ECX is my dummy. Okay. Then what I want to do is let's move into EAX, EBX, and then finally move into EBX, what's in our dummy register in this case. The effect of this is that we will have swapped EAX and EBX. Since this is something we do a lot, however, I have a special instruction. Okay? I have an instruction called the exchange instruction that allows me to exchange source and destination. It allows me to make special use of the accumulator when the accumulator is going to be one of my operands. Like move, it cannot exchange two values in memory. Like move, it cannot affect E-flags. So that's just an additional instruction we can go over. Now, adding values, we've done this a lot already. Again, in this case, we're going to add source to destination, so my result is going to be in destination. So first rule is destination. This does this operation. Destination plus source, store the result or the sum in destination. Okay? Source remains unchanged. Destination will be overwritten with the sum. The operands can be byte, word, or double word. Register memory, again, source can be immediate. I have addition that works for signed and unsigned addition. Well, this addition works for both signed and unsigned. I also have another instruction called increment, INC, that allows us, since we add one to a loop counter or things like that quite frequently, I'll have both an increment and a decrement. So for addition, what I'm doing, that is the same as add 1 to destination. Okay, so those are equivalent to each other. And since I'm adding, this will affect E-flags. And we've already looked at that, seen some examples of how that works. So let's look at the subtraction instruction. This is going to behave very similarly. In this case, destination will hold the difference between the destination and the source. Source will remain unchanged. Destination will be overwritten with that difference. Okay. The sign or the operands can be byte word or double word. Again, destination can be register or memory. Source can be register, memory, or immediate. This will work with signed and unsigned subtraction, and as was the case in addition, I have a decrement version of subtraction that does the same thing as subtract 1 from the destination. And again, I'm doing an arithmetic evaluation, so this will affect E-flags. Okay? One note on this. Add and subtract, these operands are fastest when both operands are in register, and slowest when the destination operand is in memory. We might want to talk about why that is. Okay, so remind me, let's talk about that. It's interesting to note that it's faster to add memory to a register than register to a memory. Again, we'll talk about that. Okay. Again, we will have covered this by the time that maybe we get to this instruction, but add and subtract operations when one of the operand is the accumulator is going. I've got some opcodes that will allow me special access to the accumulator. What that means is I can store an instruction in fewer bytes. Okay, let's do a couple. No, let's wind it up here. We'll continue in a minute.